Good day, everyone. We're the group 4, and we're here to discuss the lesson 4 entitled The Nano World.
Nanotechnology is an advanced field of science that studies and controls very tiny materials to create nanotechnology. It is improvement aspect of life. But before learning into it, it's important to understand it is and how it is started. Nanotechnology is a science of making with materials at a very tiny scale, called nanoscale, which is about 1 billionth of matter. At least living materials can have unique properties that make them stronger, lighter, or more efficient. Scientists use nanotechnology to create new tools and products that can store molecule energy that improve environment and even food production. For studying it more uses, it's important to first understand nanotechnology really means and how it began. From the early ideas of scientists like Richard Feynman to the formal development by Professor Mario Taniguchi, the nanotubes that are size range between 1 and 1 billion meters, which is extremely small, about 1 billion of meters. At this level, materials can look and behave very differently from their larger forms. There are many types of nanomaterials such as nanoparticles, nanotubes, nanowires, and nanoplates, each with unique shapes and properties. Comparing these materials with those we see every day, so we have to understand how tiny they are. Knowing their shape and size is very important because it affects how they function and how they can be used in technology, medicine, and other fields.
For nanomaterials, it focuses on how scientists see and study nanomaterials using special tools. Since nanomaterials are too small to be seen with regular microscopes, scientists use advanced instruments like the scanning electron microscope, transmission electron microscope, atomic force microscope, and scanning tunneling microscope. These tools, developed by different inventors, are very important in nanotechnology because they allow researchers to observe, measure, and understand materials at the nanoscale. Nanomaterials are so tiny that they cannot be seen using ordinary microscopes. So, scientists use advanced tools to observe them. These include the scanning electron microscope, which show detailed surface images, the transmission electron microscope, which allows scientists to see the inner structure of materials, the atomic force microscope, which scans surface using a sharp probe to create 3D images, and the scanning tunneling microscope, which can even view individual atoms. Each of these tools was developed by scientists to help explore the nanoscale world. They are very important in nanotechnology because they let researchers understand how nanomaterials look, behave, and can be used in different applications.
Nanomanufacturing is the process of making and applying nanomaterials to create improved products. It uses domain methods, bottom-up fabrication, which build materials atom by atom, and top-down fabrication, which breaks larger materials into smaller nanosize parts. Various techniques such as deep pen, lithography, self-assembly, chemical vapor deposition, knife, noise, print lithography, molecular epitaxy, rotor hole practicing, and atomic layer epitaxy are used to create precise nanostructures. This process helps develop products with better strength, efficiency, and performance in fields like electronics, medicine, and energy. Nanomanufacturing is a process where scientists and engineers create materials and devices at the nanoscale to make products stronger, lighter, and more efficient. It works in a two main ways: the bottom-up approach, where materials are built atom by atom or molecule by molecule, and the top-down approach, where larger materials are cut or shaped into nanosized structures. To do this, different techniques are used, such as deep pens, lithography, printing patterns with a tiny tips, self-assembly, letting molecules organize themselves, chemical vapor deposition, building thin layers using glasses, and others. These advanced methods allow precise control over materials, leading to high-quality products used in electronic, medicine, energy, and other industries. Nanoscale materials have unique and powerful features that make them different from ordinary materials. At this tiny scale, they show quantum effects, greater surface area, and higher reactivity, which change how they look and behave. Many biological structures like DNA and hemoglobin are also at the nanoscale. These special properties make nanomaterials useful in studying cells, creating new materials, and improving technologies and medicine. So nanoscale materials are very small substances that behave differently from normal sized materials because of their unique properties. At this at this tiny level, they experience quantum effects, meaning meaning their color, strength, and electric elec- electrical behavior can change. They also have a larger surface area compared to their size, making them more reactive and efficient in chemical reactions. Many natural things, such as DNA and hemoglobin, exist at the nanoscale, showing that nature itself uses nanoside structure because of these special characteristics. Nanomaterials are widely used in medicine, electronics, and research sensing. Scientists develop better treatments, stronger materials, and more advanced technologies. Global and local nanotechnology efforts. Global and local efforts in nanotechnology involve government programs and research from countries like the US, Europe, and Japan, as well as the Philippines. Own projects in areas such as ICT, health, energy, environment, and agriculture. This initiative aims to use nanotechnology to solve the world problems like disease, pollution, and energy shortage. However, they also considered with ethical concerns to ensure safe and responsible use. Overall, nanotechnology plays an important role in society, global cooperation, and addressing modern challenges. So around the world, many countries are investing in nanotechnology research and programs to improve life and solve global problems. Nations like US, Europe, and Japan lead in developing new technologies while the Philippines also applies nanotechnologies in areas such as health, energy, environmental, ICT, and agriculture. These efforts aim to address issues like disease, pollution, and lack of clean energy. At the same time, science and government are careful to study the risks and ethical safely and responsibly. Overall, nanotechnology encourages international cooperation and it plays role in finding modern solutions for a better and more sustainable future.
So, for the key points of all the topics, introduction to technology, nanotechno- introduction to nanotechnology, nanotechnology studies and uses very small materials from 1 to 100 nm to improve products in health, energy, and in the environment. How small is the nanoscale? The nanoscale is about 1 billionth of a meter, where materials change properties based on their tiny shapes and sizes. Viewing nanomaterials, scientists use advanced microscopes like SEM, FEM, AFM, and SEM to see and analyze nanomaterials. Nanomanufacturing, nanomaterials are made through bottom-up, building atoms, and top-down, shrinking materials. Methods for use in electronics and medicine. Distinct features of the nanoscale. At this scale, materials have unique traits like quantum effects, high reactivity, and large surface area. For the last topic, a global and local nanotechnology efforts. Countries worldwide, including the Philippines, use nanotechnology to solve global issues while promoting safety and ethics. For the summary,
Nanotechnology is the study and use of materials at the nanoscale, 1 to 100 nm, to create advanced and useful products. At this tiny scale, materials have unique properties that make them stronger, more reactive, and more efficient. Scientists use special skills like tools like more reactive and more efficient scientific SEM and then microscope to see the materials and advanced methods like photo and after fabrication to make them nanotechnology is applied in health, energy, environment, and agriculture, and is supported by global and local efforts, including the Philippines to promote innovation while ensuring safety and ethical use.
that's all. Thank you guys.